Hello everyone. In this video, I would be sharing my interview experience with Blinkit when I interviewed at Blinkit. So this was one of the problems which you are looking at on the screen. This was asked in the first DS Algo round. This problem is a very common problem which is asked in interviews. I have seen other interviewers also asking this problem, and even myself, I have asked this problem a couple of times. So let's go through the problem, and I will tell you what interviewer expects from you when he gives you this problem statement. And so the problem statement is: given an integer array nums and an integer k, return the kth largest element in the array. Note that it is the kth largest element in sorted order, not the kth distinct element. Can you solve it without sorting? All right. So basically, the problem statement is: you are given an array, right? And if you sort that array, you have to return the kth element, basically the kth largest element, right? So someone can ask you, tell me the largest element, tell me the second largest element, or the third largest element, right? So it is very straightforward to just sort the array and return the kth largest element, because you would know the index. What you can do is you can sort your array in reverse order so that largest element is on the left side, and given k, you just return the element at k minus 1th index. But the way interviewers generally ask this problem statement is, they will ask you that you are given an array, you have to find the largest element in this array. How will you find it? So it is pretty straightforward. What you would do is you will iterate through your array, and you will initialize some max element. You will initialize it as the first index element, whatever is there in the first index, and you keep comparing through the elements, and you just return the max at the end. So this way you can find the largest element. Now someone can ask, the second largest element is what? So again, this is simple. What you can do is you can iterate through array. You can maintain two variables like the largest and second largest, right? And you can keep comparing both of them with the element. If the current element is greater than this, then you update second largest, and then you update largest. If it is between both of them, then you update the second largest, right? At the end, you would have the second largest. Now interviewer will ask you, how would you find the third largest, right? So at this point of time, what interviewer is asking, that this first largest, second largest, third largest, that he is asking, he wants to say that this can be configurable. He wants to give you a query, find the kth largest element, right, in the array. And now what he will say is, forget about the array. You have a stream of integers coming in. Like, you don't have n number of integers. Like, there is some function which is keep giving you some integers, and you need to maintain, like, out of all those elements, which is the kth greatest element, right? And sometimes interviewer will say straightforward like this, that you need to solve it without sorting. So what are they looking for in this when they ask such a question? So they are basically trying to see your knowledge of heaps, because whenever you see like k largest, k largest, k smallest, or first k, something like that, so that problem is generally related to a mean heap or max heap. And this kind of problems are little tricky also, because people get confused which kind of heap they should be using, right? So if you look at this, if you want to maintain the kth largest element, what kind of heap we should be using, right? So if I have to use mean heap, how would I solve it with mean heap? What I would do is, in mean heap, I will insert the first k elements, right? And what I would say is, I am keeping a mean heap of k size, right? So there must be a constraint that we have at least k elements, right? So now in mean heap, what you would do is you will insert the first k elements, right? Now the mean element is on the top, right? Now your current element, whatever is number, either it can be less than the top, it can be greater than the top, or it can be equal to the top, right? So if your current number is less than top, do you think that this number is a candidate for a main heap, or basically to replace some element in the heap? So if your top element in main heap, your top element is the smallest element, right? So what you are maintaining is, if you see this way, that I would maintain k largest elements in the heap, and towards whenever you ask me the kth largest element, I will return the top of the heap, because you know there are k minus 1 elements in heap which are greater than the top element, right? So this is one way where you can use a main heap, because what you do, you insert first k elements from the array into the heap, right? And since your heap is a main heap, so your top is the smallest. So when you are iterating through rest of the elements in your array, right, what you would do is you would compare that to the top. Now if this element is greater than the top, then you know that it is a candidate for the k largest element, because your heap maintains k largest element. So what you do is you remove the top element from the heap and you insert that number into the heap, and next whatever comes on the top for that heap, that will be your kth largest. That's how you can solve it with main heap, right? And let's say if you would have to solve it with max heap, how would you solve it with the max heap? So when it comes to max heap, what you have is top element is the largest element, right? Now if you maintain a heap of size k, right, so you have k largest elements, and from those k largest element you have the largest element on the top, right? So this doesn't really help, because the question is to find the kth largest element, not the top elements, because whatsoever you have in the heap, you would always have the largest element, right? So if you have to solve this using max heap, then what you need to do is, so this solution can be used only when you have a fixed size array. What you do is insert all elements in the array, right, in the heap, whatever max heap you have. So now you have n elements in the heap, right? And now what you would do is you will pop k minus 1 times. So what just happened now, you have all the elements in the heap. When you pop from the heap, the largest element from those elements get removed, because top is the max, right? So when you pop k minus 1 times, so you remove the top element k minus 1 times. So basically every time you're removing an integer from the heap top, so now you have removed the k minus 1 largest elements from the heap. Now when you pop again, so this is the kth largest element, right? So this is how you can use both the heaps. Basically you can use either main heap or max heap, right? And which one you should be using? So I think more in terms of being memory efficient, main heap is more memory efficient, because in case of main heap, size of main heap is basically k at any time, not more than that. But in this one, size of max heap, it reaches n once, and then you keep taking out the elements from there, right? And in case of stream, you won't be able to do this, because when in stream you're removing the elements, you will lose count of how many elements you would have removed, and you might end up removing more than k elements. Then you wouldn't know what was the kth element right now, right? So let's solve this problem using main heap. Let me change it to Java. I generally code using Java, right? So you need a priority queue of integer, right? Now what you do is for a count, okay, let's do one thing. You are iterating through your array. Let's iterate using this. We don't need index nums. What you do is you simply say priority queue dot add num, right? And now if the size of your priority queue is greater than k, then you simply pause, because you want your priority queue to be of size k, right? Because when you have k elements in your main heap. But now see this thing, when you should be adding to your priority queue and when you should not be adding to your priority queue. I think that part is lost since we moved to Java. So see this thing, what we were doing is we need to compare the current element. So if your priority queue size is less than k, you simply insert it. You say add the current element to priority queue. Otherwise what you do is, if your current element is greater than the top of the priority queue, right, only then you add the number, and basically you can poll also from there, right? So this is how at the end of loop you would basically so this should come here only, because if you are adding an element, you only then you should be taking out the another element, right? So at the end of this for loop you would be left with just k elements in the priority queue, right? And the top element is the kth largest element in the priority queue. That's what you need to return. So let's return priority queue dot peak is what you need to return, right? Let's do a quick run. So it says Paul doesn't exist. Okay. Cool. So it gives correct answer for both the cases. Let's submit it. Cool. So this worked. And let's quickly look at the time and space complexity also for this solution. So talking about space complexity, you are using additional space of k. So your space would be big O of k. And talking about the time complexity, so what you are doing is for the size of array, you are iterating through each element. So this adds big O of n factor. And this priority queue operations, which are basically priority queue dot add or poll, these are basically log of n operation. So n times you end up doing either this operation or this operation. Basically these are 2 or 3 operations which have log n. So time becomes n log n, because n is for iteration and log n is for the priority queue operation. That becomes your time and space complexity. So this is how you can solve problem like this, finding k's smallest element or largest element. All right, keep practicing. I will share other interview experiences also with you. Thanks everyone.